Okay, I'll now do a demonstration of how to do a Venn diagram in three variables. So what happens here, you'll have a situation where you'll have three things that could happen. So in this particular situation, people in this village could either, they could go to the haunted house or not. They could go to the pet cemetery or not, or they could go to the zombie land or not, or they could go to two of the three, or they could go to all three of them. So anyway, this is what it says. In Sven's hometown, the people have three Halloween activities they can go to. 46% of the people went to the haunted house. 37% went to the pet cemetery. 25% went to Zombieland. All right, then 15% went to both the haunted house and the pet cemetery. 11% went to both the pet cemetery and Zombieland, and 9% went to the haunted house in Zombieland, and then 5% went to all three of them. So I realize that's pretty complicated, but a Venn diagram is going to make this a lot easier for us. So if you were to randomly select one of these people, it asks us to find these probabilities. Whenever you're given a situation where you got these probabilities and you're given overlaps, the probability of both things or of all three things, a lot of times a Venn diagram is the way to go. So what we'll do is we'll make three overlapping circles. So this represents the people that went to the haunted house, and there's 46% of them. So I'll put like a 0.46 up at the top of it. And so then this represents the people that went to the pet cemetery, and that's 37%. So I'll put 0.37 for there. And then this represents the people that went to Zombieland, which is 25%. And so that's Z for Zombieland. So then it says 15% went to the haunted house and to the pet cemetery. That's this football-shaped region right there. Those are the people that went to both the haunted house and to the pet cemetery, and that's 0.15. So that is the area of that region. Then we have 11% went to the pet cemetery in Zombieland. That's this overlapping region there. And so that is 11%. So I'll put 0.11 right there. And then we have people that went to both the haunted house and Zombieland. That is this area here, this football-shaped region. So that's 0.09. And then it said 5% went into all three. And so that's this region right in the middle, 0.05. Okay, now what we're going to do is we're going to realize, first of all, this whole thing, this whole sample space, which is all the people in Sven's hometown, it has to add up to 1. Okay, so I'm going to find the area of each of these other regions. We've got 1, 2, 3, 4, 5, 6, 7 regions inside the circle that people can be a part of, and then 1 region on outside. Then that represents the people that went to none of the activities. So you start from the inside and you go out. Let's start with this football-shaped region. People went to the haunted house and to the pet cemetery. Well, that's 15% of people. 5% went to both. So if you subtract those two, 0.15 minus 0.05, that's 0.1 or 10%. So 10% of people went to the haunted house and to the pet cemetery, but they did not go to Zombieland. So that's what that represents. Then if you looked at this football-shaped region, it's 11% of people. 5% is there. That means 6% has got to be there. Got to be there. If you subtract those, that's got to be 0.06. Like that. And so then if you look at the third football-shaped region, takes up 9% of the population. So if we subtract that, that'd be 0.04. So the two parts added together is the whole, and that 4% would be people that went to the haunted house and went to Zombieland, but did not go to the pet cemetery. And so any of those questions could be asked of you in essence, like what percent went to the pet cemetery and Zombieland, but not the haunted house? And that's those people, the 6%. Then we have on the this here. This represents the people that went to Zombieland, but none of the other two. And so if I say the whole thing is 25%, that's 4%, that's 5%, and that's 6%. If I subtract those, 0.25 minus 0.04 minus 0.05 minus 0.06, it ends up being 0.1. So 10% went to Zombieland, but not the other two. Then, if I look at this circle, it has an area of 0.46, and if I subtract off these three areas, 0.46 minus 0.1 minus 0.05 minus 0.04, that's 0.27. So when you add up these 4 areas, it adds up to that whole circle. And then lastly, with the pet cemetery circle, if I say 0.37 and I subtract off these 3 areas, that's 0.16. So that if I add 0.16 plus 0.06 plus 0.05 plus 0.1. Then lastly, it's the area of the outside. Now, the whole thing has to add up to 1. So when you look at the area of all 7 of these regions here, okay, and add them up, okay, 1, 2, 3, 4, 5, 6, 7, all right, and the outside has to add up to 1. So if I say 1 and then I subtract off 0.27, 0.10, 0.4, 0.16, 0.06, 0.05, 0.04, and 0.1, it ends up being 1 minus 0.78, and that's 0.22. And so now I've completed the Venn diagram. All right, and I can answer whatever questions are being asked. So if you were to randomly select one of these people, what's the probability they wouldn't go to the pet cemetery? Well, 37% went to the pet cemetery, so that means 1 minus 0.37, and so that would be 0.63 that did not go to the pet cemetery. So that would be the complement, as we'd say, of pet cemetery. What about go to Zombieland but not the other 2? Well, go to Zombieland but not the other 2, that would be this area here, 0.1. It's in the Zombieland circle, but it's not in the other 2, so that's just 0.1. Go to at least one of the activities. So at least one means that's the area on the inside. If you added up all of these 7 areas of these 7 regions, that would add up to 0.78. And then lastly, go to none of the 3. Well, none of the 3 would be 1 minus at least one of them. So it's 1 minus 0.78, and that's 0.22. In other words, it's the area on the outside of the circle.